to record. Happy Friday. Friday, substantially fewer people in class. That's classic. That's all right. It's just a little quickie. 50 minutes. You won't even feel a thing. All right. So to pick up from where we left off last day, I'm just going to grab this, I guess this whole page. Copy. Nice. Okay. So we looked at two different scenarios, right? Depending on how we found the median, that determines how we find the quartiles, just as a quick review. And I'll just say from last day here, which was just yesterday, I guess, right? In this scenario, right, the median was neither of these numbers. It was the average of those two numbers. And so to find Q1, which is the first quartile, right, then we start at the 4.6. As opposed to the second scenario where we have one less data point, right? Then I use 4.6 as the median. So then my quartiles, I have to start from 4.4 and count in, okay? So that's the key difference. And then I quickly ran through and I said, okay, the interquartile range is exactly like the words say. It's the distance between the quartiles. Okay? And so we calculated by Q3 minus Q1. And so we found that the spread, right? The interquartile range is a measure of spread. So the spread for this smaller data set where we removed one data point, 9.4, I think it is, yeah, was smaller than the previous one, 1.8, right? So just a little bit wider. Okay, and so, which makes sense, right? We took out 9.4, tightened it up a little bit, and so that's reflected in the interquartile range. Okay. So we're going to keep working on this today, and we're going to keep these interquartile ranges in our back pocket. Okay. And so I'll call that kind of the end of the review, I guess. Just notes from last day. It was just yesterday. Yeah. Feels like just yesterday. All right. So one way that we can summarize data is using what we call a 5-number summary. Okay. And so one common way. Yes. 2.1 all week. It's a big section. So one common way of summarizing data is using a 5-number summary. What is the 5-number summary? The 5-number summary is, we start with the minimum. Wait. Looks like I crossed it out there. You start with the minimum, then you list your Q1 and then your median, right? We're just going through those cutoff points that we found, then Q3 and then your maximum. So that's your 5-number summary. There will be a question on the quiz. Tell me what the 5-number summary is, right? What does that entail? It means that you have to sort your data, right? And find the median, find the quartiles, right? Just like we did. Minimum and maximum, those are easy points, right? We can find those if we've sorted properly, right? And so those are going to give me marks, right? But there's a little bit of work, right? And so that's how I ask you to calculate the median and the quartiles, right? Is by saying, what is the 5-number summary? Okay. And I'm gonna just bump this down 1, because what I want to do is I want to do the 5-number summary for both of these. Okay. What can I call these? With 9.4, without 9.4, does that make sense? Right? I want to summarize the names of these data sets. I didn't name them anything, but let's say the first data set is GDP with 9.4, and then I want to do GDP without 9.4. Right? We're going to find slightly different 5-number summaries. The minimum, Q1, median, Q3, and the maximum. So like I said, I like to start with the minimum and maximum, just quick wins, right? 2.9, 9.4. Right. The median, I think I remember 4.65. I'll just double check here. 4.65. And then just so I don't have to scroll around so much, 4 and 5.8. 4, 5.8. And what was it? 4.65. Thank you. So that's the 5-number summary. Is there a question in the back there? Ladies? Hey. Same thing, GDP without the 9.4. Minimum is still 2.9, but 7.3 is our maximum. And 3.9, 4.6, and 5.4. So now I have these 5-number summaries for each of them. I'm also going to jot down the interquartile range for each of them, just so we have all this information. The interquartile range in the first one was 1.8, I think. And for the second one, thank you, 1.5. Okay. So slight differences, nothing major, right? But obviously it'll make a difference to your answers, right? Okay. Now, these numbers, although they do tell us a lot of information, right? Because the distance between the minimum and Q1 is 25% of your data, right? So if these values are really close together, right, relative to the other distances, then what does that mean? It means that a lot of data happen in a short amount of time, right, in a short distance. And so in terms of a histogram, what does that look like? It looks like a huge stack of data, right? And so, but that's very difficult for our brains to look at these numbers and go, oh, wow, I see the distribution so clearly now. No, we don't, right? That's hard to do, right? And so, so to visualize this 5-number summary, what we use is called the box plot. To visualize, maybe I should say a 5-number summary, because we have 2 of them. A 5-number summary, we use a box plot. So it's another way that we can visualize the distribution, okay, of numerical data. Now, I find that probably the easiest way to talk about a box plot is just to show you a box plot, and then I'll tell you the anatomy of it. Okay, and I realized I didn't have it in the numerical summaries page that I posted. But a box plot looks like this. Wait. I'm having a slight, just my daily panicky, did I record? I am. Okay. Moment. It always happens. All right. So here's a box plot. There's a box, surprise, and it's a plot. Okay. And so we can recognize a box plot, but how do we read a box plot? So notice that here the axis, it actually starts at 3, right? So it doesn't necessarily start at 0. So that's something to keep an eye out for. And then it increases this way. So where I start with the box plot is here in the center. In the center, we have the median. Okay, remember, it's just a visualization of the 5-number summary. So here, this is the median. Okay. Then what we have is down here, we have Q1, and then up here we have Q3. Okay, and so the quartiles make up the box. Okay. There's no reason it should be this wide. It's just to see what's happening here, right? There's no, I don't know, there's no kind of logic to it, but I'm sure there is some study on how our brains process visuals, all that kind of fun stuff. Okay. So here, this is Q1, and this is Q3. Okay. Then what we have are these, sometimes we call them fences, sometimes we call them whiskers. And because whiskers sounds way cuter, I like to use whiskers. So these are whiskers here, right? And the whiskers are kind of special. They are, I shouldn't say kind of special, they're really special because they extend as far as the data goes without being an outlier. Okay? Anything beyond those whiskers are considered outliers. Okay? And so here, these two are whiskers, which makes this little guy, or I can use blue. This little guy is an outlier. Okay. And then same thing here. This distance is the interquartile range. Okay. So let's talk about those whiskers, right? Because that's the next thing that we have to deal with is, okay, so the whiskers extend a prescribed amount, and I'm on purpose not telling you what it is quite yet, okay? But there's a formula that will apply, and they extend to a certain point, and then anything beyond that is going to be considered an outlier, right? And so that's why we have that little dot showing that it's an outlier, is because it's beyond those whiskers. Okay? And so the whiskers, I'll write it here. The whiskers extend to either the max or the minimum values, right? Because we have two whiskers, one on each side, right? And so here on our lower whisker, there's no outlier here, right? So this whisker just goes to the minimum value, right? And so that's what I mean by it either extends to the maximum or the minimum, or, and I'll say values, or okay, the most extreme value, so the most extreme data point within some upper and lower bounds that we're going to find. Okay. Or the most extreme value within the upper or lower bounds. Okay. So these bounds, upper and lower bounds, or I guess I should also include the upper and lower bounds. These bounds come from what we call the 1.5 IQR rule, okay? And it's just the most established way of identifying outliers. Is there a reason it's 1.5? I'm sure there's a sound reason. Could we use 2? Sure, that's someone else's rule, right? Could we use 1.75? Of course we could. That's probably someone else's PhD defense, right? And so it's just 1.5 was decided on because it highlights, sorry, this is insane. Can anybody see me? It highlights, I'll get up soon, I'm sure, but it highlights outliers without being too kind of extreme, right? We don't want to have these huge bounds because we want to pick out outliers, but we don't want to be too kind of jump the gun and say that's an outlier, right? And so 1.5 is the trade-off that's been decided on, okay? And so that's the one that we use the most, okay? So to identify outliers, we use the 1.5 IQR rule. Okay. Which, I guess I'm not going to say which entails is what I was going to say. I'm not going to say that. We need to find some upper and lower bound. Okay, so some kind of threshold where we say anything beyond this point on either end, right? So we're going to have a lower end and an upper end. Anything beyond this point is considered an outlier. Okay, and so we need to find the upper and lower bounds. Okay. So the lower bound is, yeah, I knew I was going to get up. The lower bound is going to be from Q1. You're going to go down 1.5 times the interquartile range, right? Hence the name 1.5 IQR rule. You've got your interquartile range. Now you multiply it by 1.5. You got to make it a little bit longer. And then you go down from Q1. What does that look like in terms of the math? Well, the lower bound then from Q1, you have to go minus 1.5 times the interquartile range. Okay. If we apply the same idea to the upper bound, this is where I want you to be super, super careful. If I go from Q3 and I subtract again, that just bumps me down. That doesn't make sense, right? So you have to be really careful that you go from Q3 and you add 1.5 times the interquartile range, right? And so that's the difference. But if you're thinking about it kind of visually, that math will make sense, right? So the upper bound is going to be Q3 plus 1.5 times the interquartile range. Oops. Okay.
Is that the point with the horizontal line, the whiskers and outliers?
Not really. So, okay. So the whiskers either go to the maximum or the minimum value. That's easy, right? but you have to check your fences first or your bounds first. So what happens is these are not data points, or sorry, the bounds are not data points, right? And so these whiskers extend to the data point that's the furthest, but within the bounds still. Okay, and we'll do an example so you can see it. But that's really important to remember here. So let's make a note. Okay. Note, these are not data points. So they are not included in the final box plot, right? We use them to draw the box plot to determine where the whiskers go to and what's an outlier, but they're not included in the final box plot.
Sorry, Emily.
Yes?
It's just, if we scroll up just a little bit, it
Sure.
does say to identify outliers, we use the 1.5 IQR rule, and I'm a bit confused how that determines our outliers and our bounds. I guess because
Well,
when we
have
find the bounds, we
so
know it's an
let's-
outlier.
I'll show you an example,
Perfect, thank you.
which was my next thing.
Sorry.
You're just getting ahead. That's all right. In fact, I encourage it. So, okay. So what I'm gonna do is I'm gonna start with this mess. Okay? We did all that work, and now I'm going to paste that in here. Okay. I will delete these boop, boop, boops because we don't need to show how the sausage is made, do we? Okay. Okay. Let me just clean this up a little bit. Actually, let's put it on a fresh page here. Okay. So I'm only keeping what we need. 5.8. Try to remember. Okay. So we found the IQR. Okay. So now what we're gonna do is I'm gonna find the lower bound, which was Q1 minus 1.5 times the interquartile range. Wait. Okay. So we need Q1, of course, which is 4.0 minus 1.5 times the interquartile range, which is 1.8. You have to be really careful here, right? If it's been a while since you did any math, you need to multiply these two together before you subtract them from 4, otherwise it makes a mess, right? I know you guys are chuckling, but it can happen to anyone if they're not careful. All right, so, okay, now, or maybe that's just, I'm used to teaching Stat 121, where they're just first years, like truly first year students, fresh out of high school. They can mix things up sometimes. You guys are usually fine. So I get 4.0 minus 2.7, and 4 minus 2.7 is 1.3. So what I do now is I draw a line at 1.3. So luckily I have my data sorted, right? Because then if I were to draw a line at 1.3, I would see that, okay, 1.3 is on the lower end, right? And so then that whisker from the box plot, right, is drawn to either the maximum or the minimum value, or the most extreme value within the bounds. Okay, which is the maximum and minimum if there are no outliers, right? So in this case, right, here, I see that. So I like to draw 1.3 here. It's not a data point, right? It doesn't become part of your data, it's just the threshold, okay? But 1.3 would go there, and so I see that, okay, there's no data beyond there, so there's no outlier on the lower end. I still have to check the upper end, right? But, so what we're gonna say is, since there are no data points beyond 1.3, there are no outliers on the lower end. We're still going to do that with the upper end. Okay. From the box plot, right, I suspect that there probably is going to be an outlier. So let's see here. So let's do the upper bound. Remember, it's Q3 plus 1.5 times the interquartile range. Q3 was 5.8 plus 1.5 times 1.8, which I already found was 2.7. 5.8 plus 2.7 is 8.5. So now I take this 8.5 and I draw a very long line up here. 8.5 on my number line, right, would separate the 7.3 and the 9.4, right? So this tells me a few things about my box plot. Well, my 7.3, that's where my whisker would go to, right? Because the whisker goes to the most extreme value within the bounds. Okay, so it would go to 7.3, and then 9.4 I would indicate is an outlier using either a dot or a star, or whatever symbol you want. Okay. And so here, since 9.4 is beyond the upper bound, there is one outlier on the upper end. I'll also make a note. Note the whiskers will go to 2.9 and 7.3, the most extreme values within the bounds. The most extreme values, oops. Within the bounds. Yes. No problem.
That horizontal line is 2.9 and 17.
Yes. So here, I'm going to go back here. And this is going to go to 2.9 and 7.3, right? Because those bounds, it's really important that you don't build them into your box plot, because the box plot is for data only, right? But we use the bounds to say, okay, this is an outlier, these are not, right? I should put them on the same side. That was weird of me. There. Right. Nice.
Can we say that 2.9 is lower bound as well as in this case?
Yes. I've been using the term bound in this scenario, right? I would know what you meant, right? But yeah, the lower whisker goes to 2.9. I'd be careful about calling this lower bound because the lower bound, right, we just found is 1.3, not 2.9. So you want to be really careful about the terminology. But that's, yeah, I'll know what you meant, but I'm pretty picky about that kind of stuff. Words matter. But yeah, the lower whisker is at 2.9. Okay, good. So if you are in data science, and potentially even if you're not, you have probably got a handle on the summary command, right? It's the first thing we do once you get a data set. I tend to use just the summary command, right? And so here I've applied the summary command to the GDP data that we have that we've been working with. And one thing to mention is that the summary command is just the 5-number summary with the mean as well. And I'll tell you why the mean is included, right? But here, this is the 5-number summary. Notice, right? The minimum and the maximum should be the same for all of us, right? But I mentioned briefly last day that it's possible that the quartiles and the medians are not necessarily the exact same as what we find by hand, because we only have so many tools, right? We don't want to spend too much time doing weighting and all that kind of stuff. But because it's built in, right, it's going to be slightly different. I think we had 5.8 here, right? And so these are slightly different from what we found by hand. And I'll just make a note that that's because it uses fancy weighting that we don't. Right? So if you're checking your work, don't freak out if it gives you kind of slightly different numbers. Minimum and maximum should be the same, yeah. But the quartiles, right? First, second, third, second is the median. Those will be often a little bit different, right? Nothing crazy. I think our first quartile was what, 4.0, and here it's 4.05, right? So you can kind of convince yourself that you're on the right track, right? And so, but as soon as you're dealing with a real data set, you'd use the summary command. But of course, the way you interpret the quartiles and things like that stays the same. Okay. So here, notice Q1, or maybe I'll just say the quartiles are slightly different from what we found. Because R uses fancy weighting. Okay. But results should be similar. Okay. So one kind of cool thing that we can use this 5-number summary for, and this is for our course, obviously, but something to have up your sleeve for any sort of data analysis, is you can use the median and the mean. And of course, if you wanted to extend it to the quartiles, you could, but I rely on the median versus the mean quite a bit in trying to figure out what the distribution might look like. How would that work? Okay, so here we can compare the median and the mean to get an idea of what the distribution looks like. To get an idea of what the distribution looks like. And how? How? Boy, oh my gosh. I'm gonna copy this. Okay. We've got a median of 4.65 and a mean of 5.108. Remembering how we use the median if I have non-normal data, right? Because why? Because the mean is pulled in the direction of the tail, right? So it's pulled in the direction of outliers. So then if I compare 4.65 and 5.108, I get an idea of, okay, the median is where the main cluster is, right? For some data. So what this would look like, right? I see something like this, because the median, we use it because it's a good measure of center for skewed data, right? Or non-normal data. Okay. So here, this would be at 4.650. Yeah. And then I would have the mean of 5.108 being pulled towards the tail, right? So you can just have that numerical summary, and even though it looks like nonsense, right? It's really hard for our brains to look at. What I latch onto is this comparison, right? What am I assuming? I'm assuming that it's unimodal, right? Only one mode. That's not necessarily the case, but I'm just trying to get an idea of what's going on here, right? And so here, I'll match these up like that. Okay. And it looks so bare without an x-axis. So comparing these values, right, I suspect that this distribution is skewed to the right. Okay. So comparing these values, I suspect the data is skewed to the right. Assuming the distribution is unimodal. I'll write that down because it kind of hurts me not to write it down. I always have to state my assumptions, right? And so the first step there is to always think, okay, well, what am I assuming, right? And so that's something that I am going to try to teach you, but it's going to take longer than one course for sure. Okay. Assuming the distribution is unimodal, right? Not necessarily the case, but that's an assumption I'm making. Okay. If the mean and the median are roughly the same, right? They don't have to be exactly the same, but then what do we have? Then I think I have a normal distribution, right? Because I'm assuming it's unimodal, and if it's symmetric, then the mean is in the center, right? And so if the median is roughly equal to the mean, oops, right? Not exactly, depending on the scale of your data, right? You have to be the judge of what's roughly or approximately equal to. That looks weird. So if the median is roughly equal to the mean, the distribution is likely approximately normal. Right? Because if I have a normal distribution, like, oh, my normal distribution always lifts off on the right. Right. Then the median is equal to the mean. Right. Okay. And maybe, I don't think I wrote a note why the mean was in the upper end here. Where can I squeeze this in? Recall, the mean is pulled towards the tail. I'll do a little asterisk there. Sorry, that got weird. Too many thoughts. Okay.
We can see that, right? If mean is greater than median, it's right skew, and if mean is lesser than median, it's less.
Exactly. Yeah. So the other option would look like this, right? And so here the median might be here, because that's our best measure of center if we have a skewed distribution, and the mean would be below the median. Right? Okay. I shouldn't use pink here. I should use green. Stay consistent. There. Hopefully I didn't mix. No, I didn't. I didn't mix those up. Okay. So notice when I'm talking about distributions, right? I like to look at the shape in terms of a histogram, right? This would be basically a histogram. Okay? But the box plot also gives us the distribution, okay? But it's a little bit harder to read. So I'm just gonna nab this box plot so we can compare them. Oh, actually. Grab a freshie. If I have this box plot, and I'm gonna trim down everything I don't really need. Okay. And I tell you that this gives me the same information as this. That's weird. I don't see it immediately, right? But one thing that you can do is I like to just turn it Okay. And then, right, so just for space reasons, we usually put our box plots this way. You can ask it to turn it so that it's on its side and then it's easier to look at, right? But when I look at this now, I can see that, okay, this shorter distance means that I actually have lots of data in here, right? That's what we said. Okay, if the distance between the quartiles is small, then that means I have lots of data there, right? They're kind of piled up because you've got a quarter of your data in this distance, right? So a quarter of your data here, a quarter of your data here, a little bit more spread out, quarter of your data here, and then minus the outlier, right? So here, this short distance means lots of data, right? And so that would be kind of, well, I cropped the number line, but it would be in this range here, right? Kind of there probably. And then it takes me a little bit longer to get through the rest of them. Okay. So you can look at a box plot and still find the distribution. It just requires a little bit more work. And that's yeah. I spent my 1 minute trying to decide if I had time to cover this last little bit. No, we'll use it as a refresher. On Tuesday, I told you, blink and you miss it, these little 50-minute blocks. Anyways, if you have any questions, let me know. Otherwise, have a great weekend. I'll see you on Tuesday. You've got that tiny assignment, but nothing crazy. You're off the hook for a little bit longer.